Alright, so I want you to pause the video and try one on your own, and when you're ready, hit play to check your answer. So in this one here, again, we're talking about a square root, so we're looking about pairs here. So if I take the number 108, again, you can divide it by whatever you want to divide it by, as long as it goes into there evenly. So for example, I'll take 108 and I'll divide it by 4. And so I can break down 108 into 4 and 27. So I'm going to keep going as far as I can go. 4 is 2 and 2. 27 is 9 and 3. 9 is 3 and 3. So again, with this method, you want to look for pairs. So I can take out a 2 and a 3. So that means I can multiply this 3 here. I can multiply it by 2, and I can multiply it by 3. So 3 times 2 is 6. 6 times 3 is going to be 18. You're going to have a 3 that's left over here. And then we can say 2 goes into 2 evenly. It goes in there one time. So 18x square root of 3. This one I can break down into 9 and 2. 9 is 3 and 3. So I can take out a 3. So 3 times 2 will give me 6 with a 2 left over. And then 2 goes into 2 one time evenly. And then 48, I can do 8 and 6. So keep going here. This would be 2 and 2. This would be 3 and 2. So that means I could take out a 2 here, and I can take out a 2 right here. So it's going to be 3 times 2 times 2. So that's going to be 6. 6 times 2 is 12. We'll have this little 3 that's left over. And then we've got 2 goes into 2 evenly, goes in there one time. So I'm going to rewrite this. This is going to be 18x square root of 3 minus 6x square root of 2. And then minus, that's my fault. Let me erase that. Sorry, guys. So this is going to be minus 12x square root of 3. Now you only want to put like terms together. So if you look, the only ones you can put together would be the ones that have the square root of 3. So 18x minus 12x is going to give me 6x square root of 3. And then I'm just going to write beside it minus 6x square root of 2. Since those are unlike terms, you cannot put those together. Now to multiply radicals, you always want to multiply the coefficients, which are the numbers outside the radical, and then you want to multiply the radicands, or the numbers inside the radical, and then you want to simplify any remaining radicals. So unlike addition and subtraction, you can multiply any radicals. So like this one here, you have the square root of 6 times the square root of 3. Well, you don't have anything outside the radicals, but 6 times 3 would give you the square root of 18. Now, if you can reduce it, and in this case, you can take out a 3. And so we could rewrite this as 3 square root of 2 as our final answer. Now, if you have numbers outside the radical, multiply them first. Negative 2 times 5 is going to give me negative 10. 7x times 2x to the third is going to give me 14x to the fourth. Now, I can't do anything with 14. 14 is just 7 times 2. But I can do something with x to the fourth. 2 goes into 4 evenly. It goes in there twice. And then I'm going to rewrite that the square root of 14. So I want you to pause the video and try some like this on your own. And when you're ready, hit play to check your answer. So this one, we've got 10 times 20. So if we do 10 times 20, that is going to give us 200. And then we've got x squared times x, which is going to give us x to the third. Now, 200 you can break down. Again, it doesn't matter how you want to break it down. It's really up to you. So we can start off by breaking this down into 10 times 20. And then we could say this is 2 times 5. We could say 20 is 5 times 4. And then 4 is going to be 2 times 2. So what can we take out of the radical? We could take out a 2. And we can also take out a 5. So 2 times 5 is going to give me 10. We're going to have this little 2 here inside the radical. And then you've got this x to the third, so 2 goes into 3 one time with a remainder of 1 left over. Now here we would want to distribute. We do want to be careful when we multiply a whole number by a radical. This does not mean you multiply 6n times 8. It's only if it was inside the radical would you multiply it together. This really just means 8 times the square root of 6n. Now these two, since they're both inside the radical, you would want to multiply those together. This would be the square root of 18n squared. Now can we do anything with the square root of 6n? No, we can't. But we can do something with 18. notice you could take out a 3. And so this would be 3 square root of 2. And then you can also take out an n. 2 goes into 2 one time. So we can rewrite this as 8 square root of 6n minus 3n square root of 2. And in this one, you would want to use the full method, or you would want to just distribute however you want to go about looking at it. We're going to take 6 square root of x and multiply it by each one here. So 6 times 7 is 42. Square root of x times square root of x is the square root of x squared. 6 square root of x times 8. You can multiply the 6 and the 8 together, which is going to give you 48, and then we'd have the square root of x. Now we're going to do the 4. 4 times 7 is going to give me 28 square root of x. And then 4 times 8 is going to give me 32 here. So we would want to simplify anything that we can simplify. The square root of x squared, 2 goes into 2 one time evenly. So this simplifies into 42x. Now we can add together these two that are in the middle because they are like terms. So 48 plus 28 is going to give me 76 square root of x, and then plus 32. None of these are like terms, so this right here would be our final answer. In terms of dividing radicals, you really have two options. You can either take the division and separate it into a radical in the numerator and the denominator, or if it's already separated like the ones at the bottom, you can actually rewrite them as one radical. So let me show you this first one. The square root of 5 over 121. You can rewrite this as the square root of 5 divided by the square root of 121. And the reason why that's beneficial is because the square root of 121 is a whole number. Square root of 121 is 11. And so this would be my simplified answer. Again, if they're all underneath one radical, see if separating them helps your case here, which in this one it does. We can now simplify both the numerator and the denominator. The square root of 169 is 13. And then 2 goes into 2 one time. 2 goes into 10 5 times evenly. And so you have no radical left here. Now, if they are rewritten or written separately, see if rewriting them all underneath the same radical would actually help you. So we rewrote this as 45 divided by 9. 45 divided by 9 is just 5. So this would just simplify to give us the square root of 5. Again, if I rewrote this as the square root of x to the 5th, y to the 3rd, all over xy, could that help me actually divide these two? Yes, because 5 minus 1 would give us x to the 4th. 3 minus 1 would give us y squared. Now, can I simplify this even further? Sure. 2 goes into 4 2 times, and 2 goes into 2 one time. Now, what about if it doesn't divide evenly, or if things actually end up with a radical in the denominator? There's an agreement in math that we do not leave radicals in the denominator. It's easier to work with a radical expression if it doesn't contain any radicals in the denominator. So what we use is a process called rationalizing the denominator in order to get rid of any radicals that appear in the denominator. So let's look at an example. If putting these together underneath the same radical doesn't really help your case, try rationalizing the denominator. To get rid of a radical, if you multiply that radical by itself, the square root of 7 times the square root of 7 is the square root of 49, which lo and behold, the square root of 49 is 7. So multiplying a radical, a square root, by itself will essentially just drop the radical, and you'll just be left with that whole number. Now here's the thing about fractions though. Whatever you do to the denominator, if you want to keep it equal, you have to do the same thing to the numerator as well. So the square root of 2 times the square root of 7 is going to give me the square root of 14. Now you do want to check to see if anything can be reduced in which the square root of 14 can't. So this would be your rationalized denominator. So this would be your new fraction. Again, anytime I have a square root, I just tell students multiply it by itself. Square root of 8x times the square root of 8x is just 8x. 3 times the square root of 8x is just 3 square root of 8x. Now, can you simplify anything? Well, if you think about the number 8, you can take a 2 out of the radical. So this is going to be written as 6 square root of 2x all over 8x. Now you can't mess with the radical itself, but any coefficients, if you can reduce them, then by all means. 6 over 8, you can divide them both by 2. So this is going to be 3 square root of 2x all over 4x. Now, if you have a binomial in the denominator, so not just a square root, maybe it's a square root being added to something or the square root being subtracted from something. We multiply both the numerator and the denominator by a word called the conjugate. This is just a fancy name for, we're going to multiply it by the same denominator, we're just going to switch the signs. So instead of the square root of 3 minus 2, this is going to be the square root of 3 plus 2. So watch what happens. I'm actually going to do the denominator first. Watch what happens in the denominator when I multiply it by the square root of 3 plus 2. Well, the square root of 3 times the square root of 3 is just 3. The square root of 3 times 2 is going to be 2 square root of 3. Negative 2 times the square root of 3 is negative 2 square root of 3. And then negative 2 times 2 is going to give me minus 4. So my denominator, I'm not doing my numerator yet. Watch what happens here. Those cancel, and then 3 minus 4 is going to give me negative 1. Now up here in my numerator, I am going to take the 5 and distribute it. So this is going to be 5 square root of 3, and then 5 times 2 is going to give me 10. So this is going to be 5 square root of 3 plus 10, all divided by negative 1. Since it's being divided by negative 1, we can rewrite this as negative 5 square root of 3 and then minus 10. So watch what happens here. I'm going to multiply both the top and the bottom by the square root of 5 plus the square root of 3. So square root of 5 plus the square root of 3. I like to do the denominator first because it tends to be a little bit nicer than the numerator here. Square root of 5 times square root of 5 is just 5. Square root of 5 times square root of 3 is the square root of 15. Negative square root of 3 times square root of 5 is negative square root of 15. And then negative square root of 3 times the square root of 3 would just be minus 3. So my denominator, those would cancel, and then 5 minus 3 is just going to give me 2. Now my numerator, not so pretty. I'm going to have to fold this out here. So square root of 6 times square root of 5 is the square root of 30. Square root of 6 times the square root of 3 is going to be the square root of 18. 2 times the square root of 5 is just 2 square root of 5. And then 2 times the square root of 3 is going to be 2 square root of 3. So you do want to check everything in your numerator to see if anything can be reduced. Now 30, if you think about it as a factor tree, is going to be 3 times 10. So are you going to be able to take anything out of it? The answer is no. 18 though, we already know, we can rewrite 18, the square root of 18, as 3 square root of 2. So we're going to rewrite this as the square root of 30 plus 3 square root of 2 plus 2 square root of 5 plus 2 square root of 3. Now can I put anything together? The answer would be no, because they both don't have they all don't have the same radical, but this would be my simplified answer. So I want you to try 2 on your own where you're having to rationalize the denominator, and when you're ready, hit play to check your answer. So this first one's just a square root, so I'm going to multiply by the same square root top and bottom. Square root of 3 times square root of 3 is just 3. 3 square root of 4 times the square root of 3 would be the 3 square root of 12. Now, can 12 be reduced in terms of a radical? Yes, because you can take out a 2. So we can rewrite this as 6 square root of 3 all over 3. Now, can my coefficients be reduced? And the answer there would be yes. 6 divided by 3 would just give me 2, and then square root of 3 here. Now this last one, you're going to multiply by the conjugate. So we're going to multiply by the square root of 2 plus 1. So we're going to multiply by the square root of 2 plus 1 here as well. So my denominator, square root of 2 times square root of 2 is just 2. Square root of 2 times 1 is going to give me square root of 2. Negative, this would give me negative square root of 2. And then negative 1 times 1 is going to give me minus 1. And then that simplifies down if I just wanted to finish that out. 2 minus 1 is just 1. Now my numerator, square root of 2 times square root of 2 is just 2. Square root of 2 times 1 is going to give me square root of 2. This is going to give me 5 square root of 2. And then 5 times 1 is just 5. Now can I combine anything together? I can. 2 plus 5 is going to give me 7. Square root of 2 plus 5 square root of 2. Keep in mind there's a 1 out front, so this is going to be 6 square root of 2. So I can just rewrite this as 7 plus 6 square root of 2 here.